We're just going to take a look at some things. It's a lot of polymorph. Well, maybe. Let's just take a look at this. Oh God, this has semaphore wait for in it. It's not good. So I'm just taking a look at where things stand in terms of proportion of time being used. I don't even know if that's going to guide the activities from today, because I think what I want to profile is how often do we yield stupidly, and it's kind of hard to know what that means in terms of looking at this, except that excessive yields probably make this number bigger, and it's one of the biggest numbers, right? But I just want to look through here and just get an impression. Like, we're actually spending 40 milliseconds between these two, which is a lot. That seems kind of bad. 100 milliseconds in make polymorph from procedure call. That seems really bad. Oh, that could also be a yield thing. Yeah, that's really expensive. $47,000 calls. There's no way that we are anywhere near 47,000 polymorphs, I don't think. So that's a thing to investigate. Even this do polymorph at 11,000, I don't think we're anywhere near that. Like, this is weird because its exclusive time is 6 milliseconds and its inclusive time is 103. So where's all the time going, right? Where is all the time going? Can I explain what the columns mean? They're just different measurements, right? So this is how much time is spent in a function and everything that it calls. That's inclusive time. And exclusive time is how much time you spend in that function, not including callees that are profiled here, right? That's very standard among profilers. And then you have percentage versions of that as well. I guess for overloading, we might end up with a lot more polymorphs than we wish we did. This profiler doesn't show you inner calls. I have no idea what you mean by inner calls. Can the messages not just be sent directly to the... What do you mean? What? What? Does 3.0 plus 2.5 colony polymorph stuff? No. No, this is legit only when the procedure is polymorphic. Okay. So that's one place that we could look. And another place we could look is at yields generally here. But I kind of feel like I want to look here. Like, I want to just put some counters in temporarily that are like, okay, how many times did we enter this versus how many total results did we return, right? So like, how many of these 47,000s, and maybe we can do that in telemetry. Let me read the documentation for a bit, because there might be some cool stuff that I don't know about. Okay, that sucks. That's not a good... programming guide. I want to know if like I can do events or something. Graph game specific variables. So I could use maybe TM plot every time I don't know. Oh, I didn't see the questions above about. No, pump doesn't just pump messages, it pumps the whole compiler. That is, it is the routine that makes the whole compiler go. Is this epics now? One assumes it is. I mean, I don't know the details of that deal, but I assume it is. You tend to just use very sleepy. When I tried downloading that, I couldn't get it to work or do anything. Okay. Why can I not alter these columns, guys? Bro. Come on. Come on, bro. Oh, there we go. Infer types. Oh. Like, okay. A lot of the time that looks like it's in polymorph might be actually spent in infer, actually. You kind of can't tell because, again, it like disappears into here. We could maybe put a wrapper around that to tell. Let's see. So we call force infer. That could actually be the most expensive thing. Let's find out. Okay, boom. Boom. Timeline. Once again, go in here. I'm gonna profile zone. I'm gonna calzone it. Make polymorph from procedure call. Wait, really? What? Oh, this is backwards. Never mind. These aren't callees. This is like backwards. Okay, I was misinterpreting. Reverse hierarchy. That's what it says. I get it. Okay. Forget that then. That isn't what I thought. Let me see if the force infer stuff showed up here. I don't see it anywhere. Does that mean... Why would it not be on here at all? Oh, it's here. Okay. So 6 milliseconds, not free, but not that expensive. Right. Okay, so I was looking at reverse hierarchy. Okay. So how do I get forward hierarchy? Like averaged? I guess like it depends, right? But reverse hierarchy could also depend. Unless it makes multiple entries here for different reverse hierarchies. I mean, just eyeballing it, it looks like it's all solved for matches, right? But like, okay, why so many? Let's ask that, right? So, number one thing to do is cut down the count, right? So let's maybe get ahead of ourselves a little bit. Okay. Four, seven, five, 4, 7, 5, 6, 7, 4, 7, 5, 6, 7. All right. There is no last night. Okay. There is no last night. This is... Okay. Okay. We now are once again a very serious Wiseman score shop. Really, our Weissman score should be milliseconds, but this is just a temporary thing, right? Okay, so I want to put some instrumentation in there. So we know that we've got like 47,000 entries. We have potential to yield. Maybe we yield a lot. Okay. I want to know. I want to know what this number is. Okay. What does yield mean in this context? It means yielding. It means return false and come back later. Okay. So I'm just going to run debug build for a bit, just so we don't spam telemetry. Because we don't care about timing exactly right now. We're checking. Okay, polymorph completion 7,000. That means we're yielding 40,000 out of 47,000 times, right? Because the number of calls into the top of that routine is 47,000, right? Almost 47,000. So it's basically 40,000 yields, which is a lot. Does telemetry have a counter? I have no idea. No idea. Okay. So we enter 47,000 times. We leave 7,000 times. We complete 7,000 times. That's really not good. Okay, so I'm just going to mark up yield points. I'm going to make some. I'm just going to make some things here. And actually, you know what? Let's just do that. Okay. So let's look at where we yield. Okay. 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 So I just want to know how many of each of these happened. So if there's some kind of dominant site where it mostly happens, then that tells us what we could look at. We're going to make some hot cinnamon spice because we're having a party today. Okay. Now, what I would have expected if this were working well is that these numbers would add up to 40,000. But they don't. Let me double check telemetry's number here. We're going to change this to like, we're going to change this to 6 for a second. And we're going to put a 0 plus plus at the top because we don't know. Maybe telemetry's bullshitting us. Nope, it ain't bullshitting us. Okay. So somehow I'm not accounting for most of the exits from this function, right? Because I'm entering 48,000 times. We're yielding at this point 4,000 times, but we're completing 7. That's 11. We're missing most of them. Okay, we are now on the hot cinnamon spice train. And we also have giant brown butter chocolate cookie. Did I count every return? Well, I don't know. That's what we're going to investigate. Obviously, I didn't. Clearly, something is wrong. This is only if we report an error, so that should not be an issue. That should not be an issue, because these would kill compilation. This, this is if we don't match. So I guess we're saying most of the time we don't match, but we don't yield. Let's look for other ones. Or if we don't match here. Okay, you know what? Let's instrument these. Whoops. Okay, here's what we're going to do. So these are just polymorph fails, right? Whoops. We want to look for returns now. All right. That's a yield. That's an error. That's a yield. That's a non-matching. That's a non-matching. Okay. Okay, let's try that. That should make more sense to us. Okay. Yeah. So non-matching, this is not really yields, right? This is just our entry count that we did. So there's 48,000 entries total, 36,000 plus 4,000 yields plus 7,000, right? So let's just add these numbers. 36492 plus 3 plus 4224 plus 7675 is 48394, which is the first number. So we have actually correctly accounted for every exit now. Doesn't Visual Studio also show hot code paths? Visual Studio's idea of fast code is something that takes 1 millisecond. I'm sorry, we can't deal with that. It's just completely unusable for serious profiling. Calories per cookie, 380. Yeah, exactly. A fully optimized game with Visual Studio can do 16 things per frame. Okay. So this actually so most of the calls are non-matching polymorphs. So my hope is that wow, too much cookie, guys. That's exactly the right question. Where do the non-matchings happen? Deep in the function or early? If it's after a lot of work is done, then maybe we can catch them earlier. Maybe we can do something. Okay. I don't even know if this is going to be our real Weissman score. This is just something I got interested in. Like I decided to just open it up and be in the mindset of just learning more about how the compiler is behaving. If we don't even do any Weissman score improvements today, that's fine. Because it's been a long time since we even looked at performance. So that's what we're doing right now, is just looking. And then if we can fix some things, that's great. If it's just building up knowledge for later, that is fine too. Okay. So let's look at that. So it's site 0, non-matching 0, that is most of the returns. It's here. So we call solve for matches, and it fails, right? Solve for matches. You know what I bet? I bet almost all of this is calling overloads of array add. That like don't match. Let me just look. So we have 3 overloads of array add. And we have to polymorph both of these for a given type. Okay, here's the thing. Here's the thing, guys. When we have do polymorph, we actually let me pour my tea now before it gets too gnarly. So we actually deduplicate, right? We do this thing where we say, okay, let's run all the polymorph matching and all this stuff. And at the end, we can figure out which one it is, right? And if we already did that one, if it's a valid match, then we deduplicate it, right? Okay, what we don't do, first of all, is say, we don't record fails so that we know something failed. And we also don't, when we do the deduplication, I think it happens way later. Like, let me look for, there's like a find matching polymorph. And that's after we do everything else, right? It's after we do bakes and matching. And the thing is, a lot of the time, like say you've got an array of a given type and you've got like 50 times in your program that you add things to arrays of that type, right? Very reasonable to expect that. We polymorph that 50 times and then throw 49 of them away. So even in the success case, we could avoid this, but by matching earlier, by matching on inputs rather than outputs. Now that means that like if your modify proc decides to do something random or non-deterministic, that's no good, but that's fine. I'm willing to say that those are the language semantics, is that it depends on the input types of the procedure call at the time that you invoke it. So, Now, rather than worrying about caching successes like that, we actually need to cache fails, right? And not even cache. It's not really caching. I mean, we could treat it as a cache, but it's just more like memorizing which things failed. And it's at this one exit point, right? So why don't I just do a totally like jackass thing right now? I'm going to be a complete jackass about how I deduplicate the fails. And that's going to just say, hey, look, for any input here, we're just going to save it what the inputs were. And if you ever get the same inputs, return fail. And by the way, they're just in an array. They're in a flat array. We're not doing anything to accelerate it. So this will reduce our Weissman score, but may not reduce runtime by that much, depending. But then if that's successful, that's a very easy, like we have 70 years of computer science that's all about how to store data like that in a way that's like fast to navigate. So I'm not worried about that. Like that's turning it into a problem that we know how to make fast, right? So if I can just determine that that works and that for some reason that doesn't break our programs and stuff, and then that's the next thing. How big of an array? Well, I don't know. That'll be interesting to find out. All right, so we're gonna do the following things. Make sure my assumption with the array add is correct. Yes, well, that's what we're going to do, is we're going to start caching all these fails. Well, when we get to succeeds, if we cache the fails successfully, we'll go to succeeds after that. And for the succeeds, you know, we only, right, since 36,000 of these were non-matching and 4,000 were yields, right? That means, well, we know there's 7,675 actual polymorphs that occur. And I will bet you that that itself is at least 10 to 1, right? Like there's probably not more than 800 actual polymorphs. I don't guarantee that. I could be, sometimes I'm surprised when I look at things, but I bet that there's way more of these. Actually, when do we... Oh, here's a return that we're not accounting for. Somehow I missed this one. Wait, and somehow I missed this one. What's going on? But the numbers add up. Does this mean our fine matching polymorph is broken? Anyway, like, is this literally doing nothing? Is this in a different function? How did I not account for these returns? This is in a different function. Okay, this is in do polymorph, which is a different, so make polymorph, like compilers are complicated, right? So we were doing make polymorph from procedure call. This calls do polymorph. That's later on. And it's toward the bottom, you'll note, right? And that is the thing that does the polymorph matching. So we actually don't know how often we match. But the point being, if we match fails on the way in, then we could match successes as well. Okay. So here's what we're going to do. So first we do some setup, and I assume that okay, let's take a look at what we're going to want to base things on, because that determines where we can put these things. I think we want to know, it obviously, what's the source that we're polymorphing, whether that's a procedure or struct, right? Okay, let's just even start defining what we're doing. We're going to have a structure called jackass polymorph fails, right? And this is going to have an array of jackass polymorph info fails. And, who knows what else we're going to put there. We're going to have we happen to know this only ever gets called by the main thread, or at least I sure believe so. So we're not going to worry about this right now. Later, this would go somewhere when we try to multi-thread this else. But because we're being a jackass right now, we don't care, right? Okay. So what's a jackass polymorph info? Well, that's something like we've got a source and we've got some argument types of the arguments. Is that all? I don't know. Let's see. Like, I feel like there's more relevant information. So let's look up so an asked polymorph has, see, we don't want to over specialize to just the call, right? We don't even really care about the var args info. I just care about the argument. Yeah, let's just, you know what? I only care about this right now. If that's wrong, we'll find out. Okay. So we're going to say if jackass polymorph already failed, then what? Then we want to do probably what we do here. I guess we just return. I mean, we could set it to here just in case. But I think we just return and people see that we didn't yield. All right, I'm not going to worry about this too much yet. Let's just write this function. Bool jackass polymorph already failed. Asked polymorph star progress. And we're going to go for jackass polymorph fails. Well, if source is not equal to progress source continue. If it arrow source come on, bro. Not equal to progress argument list sorted count continue. So we're going to return false, right? Return true. Okay, so now because it's C++, we're going to have a problem. If all matching, so we can't do a double loop control thing. So we're going to say all matching is true for less than types.count I++. All right. If so we say types match exactly, okay. And we're going to trust that that works. If types match exactly, okay, wait. We don't return true, we return false. Wait. We say if all matching return true. Okay. So if the types don't match, we set all matching is false and we break. Otherwise, if we get through the whole loop, all the types matched. Okay. If they're all matching, we return true. Otherwise, we continue on our journey. Excuse me. And if we get through all the jackass polymorph fails, then we're fine. Okay. Okay. Dude, I hate C++. What the fuck? I'm just going to write out the for loop. I never... What's wrong with that one? Okay. That's actually fine. It's it dot. So we don't have visibility into types match exactly. So what do? Well, in C++, the best thing is actually to paste garbage around your program. No troll. No troll. Okay. Interp. Which means we need to pass it here. Oops. Rookie mistake. Okay. So this is actually not going to do anything because we're never registering a fail. Interestingly, we have more yields than ever before, but or more entries, but I assume that's just randomness. Yeah, see, so, you know, we have some randomness there. Be sad about it later when you have to do everything twice. You already have to do everything twice. You merely have to do things 3 or 4 times when you paste garbage. Where did I learn to write compilers? In my spare time projects while I wasn't studying for my classes in college. Or even honestly attending my classes in college. Okay. So void jackass register polymorph fail okay, we're just going to go new fail is jackass polymorph fails.fails.add. All right. We're going to say, let's say fail. Fail source is progress source. Fail arrow argument types dot reserve. Progress argument list sorted count. All right. And then for argument list sorted, fail argument types dot add get inferred types it in type. All right. Okay. So now here we'll say jackass register polymorph fail interp progress, and we'll see what that does. It's like figuring out what Chunky's deal is. We might totally destroy everything. Yeah. So for example, we destroyed it. Well, okay. The thing is, we might not be setting the state correctly, right? Like remember when we, okay, here, actually, let's just do this. Instead of returning, because I think, remember when I said this is not necessarily good? Let's just not do anything yet. Let's make sure we didn't break the program. I don't think we did. That all seemed very safe. Oh. Okay. So what this is saying, okay. Every compiler has deep, dark secrets. And what's going on here is we're using this types match exactly function. And this types match exactly function has never really been, how should we say it? It's never really been that good of an idea because it's leaning on something it shouldn't lean on. So maybe today is the day when we say the line must be drawn here. This types match exactly function expects messaging to have happened on the type info, on the type. So I actually have to add in another yield for this comparison that I'm doing to work. And I've had this problem enough that I think the real answer is to just add more code to the compiler that doesn't lean on frickin' type info. And instead just does a direct comparison between the types. And that would probably be faster too. But we're going to go super jackass, right? We're going to do the following. Dude, I just keep getting the capital letter here. That's super jackass. That's even more jackass than we were planning to be. This is like... Okay, so we're just like spinning until somebody shows up with this thing. All right, so this is interesting. My super jackass thing now is saying that we can't actually compile under this constraint for some reason. Like if we yield before entering polymorph, we won't ever message some types. Which I guess I believe, like this is a stupid thing to do, so I don't want to figure out why it doesn't totally work. I think the thing to do is I think we implement types match exactly separately from the stupid type info one. Like my heart is telling me that this is the right thing. Even though, you know, it's a little bit tempting to reduce code volume, but it's just better. And then we don't have this kind of problem, and we don't have to go super jackass to begin with. Who calls this? Baked literals match exactly. Okay. That makes complete sense if they're type definitions. Do the types match exactly? We call it under constraint constants blocks match, which actually, this is very important. This is actually called by our function that says, hey, bro, is this a duplicate? So we're actually going to want to employ this in a different way later. Okay, that's commented out. Jackass, of course, wants it. And then check for lambda argument match, which is used where? Deduplicating overloads. Okay. So like, I feel like it's fine to change the implementation of this to whatever we want. On the other hand, you know what? I don't even want to do this right now, though. I'm going to write it down. This would make me happy. This falls into the category of things that make me happy. But right now, let's not worry about it. So there are two things we could do. One is, so I have the feeling it's struct types that are causing this logjam. So instead of our super jackass going this way, we could do this. Jackass enabled is true. Instead of yielding, we're going to go And we can just see how many times we're punting because jackass is not enabled, right? Still doesn't matter. Wait, what? It must be the other one then. It must be, wait, what? I don't understand. We're learning. Wait, am I compiling the wrong compiler? No. We don't dereference any. What's going on? We get the inferred type. If there's no type info, am I going past the end of the array? I was being a little bit weird here. My brain is not understanding how this is possible. Let's just see. No, let's look at the code. Let's look at the code. Like, we supposedly check everything in argument list sorted. If the type info is false, jackass enabled is false, right? And then we don't call this. Did I really save the file? Yeah. Oh. Right, okay. So I bet, see, here's the thing. We actually can insert casts on the arguments. So what we're recording here is not actually the inputs. This is a good reason to do things the jackass way, because you find this kind of problem. What we're recording here includes like casts that we generated, like implicit casts. Let's make sure that that's what it is, but I'm pretty sure it's going to be. And those won't have gone through the messaging system yet, right? I've got old breakpoints that may be slowing us down. Let's just get rid of them. Get rid of them. Okay. Is it a cast? Okay, which one is it? Is it TA? TA. So it's, yeah, it's the one recorded in the thing. Oh, it's just the, right. Dang it, we can't tell what the expression is. We could tell actually, here's what we do. We could tell what it is if we put a thing in line 2110. So now this assertion will go off. And we can tell what's happening. Okay, so we're doing this jackass thing. And indeed, it is this assertion that goes off. But the good thing is now I can see what the expression is. And as I said, it's a cast. Okay, that's just a verification. So what's going on is while we're doing the polymorph, when we try to do a type match, some arguments before the polymorph fails, right? Some arguments might have succeeded. And we do that by inserting the cast. And the cast has its type inferred. But because this stupid ass types match exactly function that is totally my fault leans on the messaging system, and this hasn't gone through the messaging system yet, it's not good. Now, it's tempting that this would seem like a good idea because then it's just a pointer-to-pointer compare, but honestly, structurally in the compiler, it hasn't been a good thing. Okay. So my solution to this is going to be more super jackass than ever before. Hold on. Let me just make sure this never goes off. Because I want to know, like, if we can get away with that not going off for now, then nope, it does. Okay, that's not that surprising. Okay. Jackass polymorph already failed. See, sometimes it's just really hard to be a jackass in a complex system like this. I'm trying to be a jackass. So one option that I have is going off and just rewriting types match exactly, which I want to do. Yeah, I've decided I want to do that tonight anyway. However, before doing that, I would like to make progress here. And so what I'm going to do is I'm going to go hyper jackass in the following way. This is definitely more expensive because we do this every time we yield. But here's what I'm going to do. Okay, what I want to know, you know what? I want to know how many times do we disable jackass, right? Because that, if this gets turned off most of the time, then the rest of this experiment won't give me that much information. So I'm going to say, I want to know how many times do we disable the jackass maneuver? All right. Whoops, we've still got an assertion in there. I forgot. Okay. We are not, well, let's, in case we care about that, I feel like we're going to rewrite that function. We've still got, hold on. Okay. We don't actually want to do this. Okay. So jackass is almost never disabled. So we can get, so of these 48,000 calls, it's almost never disabled. So I can just go ahead and do the rest of this and get the information I want, and then we can write that other function and it's fine. Because 56 is really not very much. Okay, that I'm happy with that. All right, so if jackass enabled, we're going to do the following thing. We're going to go array jackass types, and we're going to go if jackass is enabled, jackass types, like the same thing we're doing up here when we, well, okay. We're going to go jackass types dot reserve progress argument list sorted count. This is so much jackassery, I can't even believe it. Jackass types dot add get inferred type it. Okay. Okay, so okay. Make sure that didn't destroy anything, which it shouldn't have. Okay. So why did we do that? Because now we have the types before we jammed any casts on there. And down here, when we say jackass, we only do this if jackass is enabled. All right. Okay, so here we just say for types we just add it. All right, so now we never should have anything. Let's just do that. Now we can re-enable that assertion and it shouldn't hopefully go off. Great. Okay. Now we're putting things into the jackass register polymorph fail arena. Okay. Which also means we can do this. And now this assertion also shouldn't go off. Notice how much longer it's taking because we're doing an O of n thing. Okay. So instead of, so now this was the thing that broke before. Let's just count how many times pre-crime, we're detecting pre-crime, right? So all right. All right. What's going on now? Pre-crime detected 35,000 times. Which means if we can do this a lot, if we can detect pre-crime a lot faster than we can detect polymorph solves, then we get our Weissman score from 35K, from 48K to, 13K. Now, what's the best way to do that? Who knows? Maybe it's a hash table. Probably it's a hash table. I have really shitty hash table support in the actual code for this compiler. Like our user level hash tables are much better, but within the compiler, Okay. We also cut down the number of yields, you notice, because it used to be, or did it? No, not really. A little bit. Because sometimes we do the pre-crime before the yield. Okay. This is very promising. I actually wonder how much time, I mean, we could be optimizing the wrong thing, by the way, because okay, hold on. Did our do polymorph? Oh, that has its own telemetry zone. Let's go look at how expensive that was. That's 80 or 50 in its own time. Ugh. Okay. So here's the thing, guys. We've collected the information. Okay. However, most of the time usage is from the succeeds, not the fails, right? But we could do the same thing for succeeds, right? We can have a jackass succeeds list and see how many duplicates we get in there, right? And that tells us how we could pre-crime the pre-non-crime, right? Okay, so we're going to go. Actually, here we go. We're going to go. Did it fail or not? That's just a thing, right? We're going to call this jackass polymorph results. Because, you know, this is going to be like a hash table or something, right? So we're going to say, did we already result? So if all matching, this is results. Okay. So, so we return the success or fail code here. We say result. Whoops. Oops. Can't use the word result too many times. All right. This is a result, and that's a false. But down here, where we go to the exit, we go jackass register polymorph result of true. Oh. If jackass enabled. All right. Now I'm sure I missed some of that search and replace. There we go. Already resulted bool okay. 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 See what happens here. Sure is slow. I sure messed that up. That cannot possibly be right. Whoops. Yeah, I set the wrong thing right there. And implicit cast a Boolean in C++ bit me in the ass. The type system that makes no sense. Okay. So I wasn't quite right. Of our polymorph completions, 4,700 of them, so more than half, we already knew that they succeeded. So we could cut that time in more than half. That's probably more important than detecting the fails, but we could detect the fails also, and then it's all good. Okay, here is where I decide in what way do we want to be a jackass next. I think that what I want to do is if def this stuff out so it doesn't hose anybody, and then fix that type matching. No, because that's not actually, okay, hold on. If it's going to be a hash table, I need to get the hashes of the items. And okay, if I leave jackass, if I leave the disablement in there but kind of change how it works so that we don't have to record that extra fat array that I put in there. Then we can use those pointers right now to hash, because the thing is, if I want to make this actually into a hash table, we need a hash of some kind, right? And that would be generated by code that maybe looks like the type matching code. I feel like I might have some type hashing somewhere. I don't know. But what I just realized is there's a step to do before that. And that step is we need to be able to actually use the pre-crime information here. We need to be able to return. So remember, as soon as I do this, we're going to lose. So let me just look here. Where's the match progress? Not even in this file. Let's just re-enable this, and when the thing barfs on us, okay, let's actually see. Let's just set a breakpoint on that line and then follow it up. Because obviously this isn't enough to signal a fail. I'm not sure what is. Okay, result is null. And then we dereference it right there. Wait, see down here. I see. If we're polymorphing a procedure, we could return null. If we're polymorphing a struct, for some reason we don't handle that correctly. That doesn't sound right to me. All right, let's just go cover that. So this is also a result. So here we maybe yield. I mean, we already checked that there, but whatever, we'll leave it for that case. And if we didn't get one, then I guess we return there. I don't know. That feels like it's not gonna. Yeah, like. Okay, this doesn't really make sense. Because I mean, this shouldn't be a fail. Hold on. Hold on. Hold on. Oh, I'm returning fail all the time because I'm a jackass. Okay. That's what we want to do. Because, like, I was looking at that error and I'm like, no, that's a successful polymorph. What are you talking about? Oh, it still does it. What? So now I don't believe these numbers necessarily. I don't know what to believe. Because if this is correct, I mean, let's just check our register polymorph result. False. Non-matching. Right? Otherwise, we register true. So I mean, I guess now I have to figure out why we're saying this failed. Like, there could be, remember at the beginning when I said, hey, I think I'm recording all the pertinent information? That may not have been true at all. Let's just, do I get the same error if I do? Yeah. So what we can do is just kind of kick back and see, whoops, see what is causing this. So expr is a procedure call. Okay, so when we go jackass, all right. We're going to go failed and progress source is equal to, or arrow S is equal to that. I think that'll work. No, it didn't. No, it didn't. Is this the very first time that we return a false? Or is it later? What is this interface is so bad. All right. Is this the first time? No. Wait, what? this is not, what? You're telling me we get here without ever return. See, this is where I just simply don't believe what I'm being told. You're telling me we never returned from here, and yet somehow we tripped that error. But if I comment this out, we're in Twilight Zone territory, folks. But if I comment this out, you're telling me we don't trip that error. No, we do still. When did that start? What? Oh, this is, okay. This is some kind of side effect of this situation. What did I change here? Exactly. I changed some of this stuff. Let's go look at a diff. That's why it was so confusing, because I was looking at the wrong thing. Okay. So we put that inside an if result. Otherwise, we fall down. But that shouldn't matter. And this shouldn't matter. Obviously, it does matter. Okay, hold your horses. Because, like, we shouldn't be returning null because we commented out the thing. Guys, what is going on? I'm freaking out here. What did I do? I mean, I put else's. Oh, shit. I didn't read the code, guys. I didn't read the code. I didn't read the code. I'm worried that the baby thinks people can't change. Okay, that's what happens when I don't read the code, but I don't read the code all the time. All right, so that's that. We're back to here. What happens when I do this now? Okay, this was the thing I was trying to get to that we saw a long time ago. So this is just like, look, it doesn't understand that we didn't fail, right? Somehow. Okay, I want to know, is this the first time that we return? I think it probably is. So I'm going to hit F5. No, it's not. It's the second time. But, okay. So this thing is like, it does not believe that we should ever fail. Somehow. Why does this think it was impossible to fail? So, okay, if this is indeed impossible to fail, supposedly, then we might be making it fail for reasons that it shouldn't. But this is, okay, this is error reporting. If we got here, we already screwed up. Okay, this is horrible. We're going to do even a more jackassy, horrible thing. We don't want to enable jackassery if we're trying to print out errors, because doing the polymorph is how we print out errors. Didn't matter. What is going on? Guys, I didn't expect it to be this hard to be a jackass. I didn't expect that. Okay. So here, okay. So let's see which call it is. Is it the first one or the second one? Maybe it's the same one both times. Progress source. The first one is, site. Why is site Francis of Assisi? It's probably defined later. Generating call. Okay, so the first one, it's FA8. Second one, it's also FA8. So what happens is we fail the first time, we come back and we fail the second time. Okay. So I want to know what is the other place where we... Oh, that's not what I want. I want this. Actually. Like there might be some conceptual error. So this is literally wait, why is this not resulting in returns down here? Oh, wait. What? Wait, what? Guys, here it's failed and oh, shit. Here it's success. What is even happening? What is even... That is such a rookie mistake. Such a rookie mistake. Okay, now when we register the result, okay, this is a fail, so it's false. This is a success, so it's true. Gosh. It's hard out there being a jackass. Still didn't matter. I just renamed. That is true. I did just rename. All right, well. Don't I need to invert the logic? What logic? Tell me what to invert and I'll look at it. Okay. So here we're saying we didn't succeed, so now we should return up and then return. Okay. So this is actually, it at least removed my debugging confusion, right? And what that means is now I can look and see what it matched against. Okay. Although I'm not really recording enough information. I should record the polymorph progress. Wait, what? Oh yeah, table add for these three things. Do we have overloads of table add? I don't think so. Yeah, it's literally only one function. It is a little bit of a tricky polymorph though. Well, here's what I'm going to do. I'm going to say, this is going to help me discover what we do when we fail anyway, which I should know because I wrote the code, but my brain is not big enough. We're going to say, a jackass polymorph info is going to say what the progress was. And that just lets me look at it when we say that we failed. All right, so now I can say, what did this progress say? And it undoubtedly put, no, it didn't put anything there. Where is this call? Line 992 of material. What folder is in that? We say add parameter value, just vanilla table add. Very straightforward. Very straightforward. Why is that failing? Is there some problem where I'm once again not reading the code? So we say solve for matches. Okay, wait. We're not checking for yield first. That seems bad. I don't know why that would have worked before. But like this should be up here. I don't feel like that should change anything, but maybe. Maybe it does. Okay, so what's going on is we were supposed to yield, but instead of yielding, we marked it as a failure. But the thing is, that means the code was doing the wrong thing before, but it just didn't have consequences. That's a confusing kind of a bug, but I'm glad that we found it. Like, I guess that would have only mattered if it was a symmetric procedure. No, because we return here. Oh, God. Yeah, okay. No, it's actually, we would have done the right thing because yield upon would have been set. So I had too much of a smooth brain. I mean, to be fair, the code was too subtle, right? But I didn't realize that that would happen and we would yield. And that probably made a lot of sense way back when none of this was here. But then as you add a bunch of stuff, it becomes less obvious what's actually happening. So actually the old code was not wrong. But when I added in a thing to count it as a fail, it became wrong. So now, though, you will note we successfully compiled the Sokoban game. And we're detecting 3 seashells. We're detecting pre-crime, but almost none anymore. Which seems really bad. Why did our pre-crime level drop so much? That seems wrong. That's weird. Because now okay. No, actually, this maybe makes more sense. Here's what happened, is we were accidentally counting yields as non-matches, right? Which made me think there were a lot more non-matches than there actually were. And that confusion all goes all the way back to toward the beginning of the stream, all right? Now we actually know there's not that many non-matches. It's mostly frickin' yields, all right? And then there's, you know, we use the 3 seashells about, what percentage is that? 48.24 divided by 76.75. So 62% of the time, we know about the 3 seashells. And then the rest of the time, the other 38% of the time, we don't. But that means that most of 62% of 80%. So we could cut about half off the polymorph time with a reasonable jackass. And then we just have to get a grip on the yields, which is a separate problem, right? And we're actually making those yields much slower because we're doing the jackass before the yield. We're doing like a, you know, a super slow jackass test every time we go in here. When most of the times, okay, this is weird. Oh no, it's not weird, because most of our yields obviously are going to be, all of our yields are going to be things that haven't gone through the system yet at all. That's why we're yielding, because they're not ready. So they won't be in the jackass list at all. So so yield 0, right, it's yield 1, is when solve for matches. See, okay. So in yield 1, we could push this, okay, could push this all the way out. Let's see under what conditions solve for matches. So that's waiting for a type. This one we're not sure. This one is waiting for a type. This one is waiting for a type. That one is probably also waiting for, okay. So I think we could get our Weissman score down. In the following, let's look in. Okay. We're about to do scary stuff that we haven't done in a long time. Where is sleep yield defined? Okay. So, in cases like this where we yield, if it's queued, we're going to increment this counter. Okay, and that tells us how many of these things we could sleep on with the current system as it stands. All right. In principle, if sleeping works and doesn't have bugs, which it might, because like we haven't put stress on it in a long time. Hello. Hey, Andy. What's up, dude? We're grinding on compiler stuff. Okay. So it's 100% of them are queued. Holy cow. That is the best possible thing we could have hoped for. I mean, it makes sense, but yeah. So I think we could say sleep yield infer on this thing. And is there a better place for this? Probably. So does that actually return? It says return false, but we can't quite use this macro. Can't quite use this macro, so we're going to do this because we're being a jackass today. We don't have these functions. Typer, right? Get current, that's a typer. Method, go to definition, yep. So we just go typer. We don't care how stupid or gross this is. We just, oh, what? That is not a typer. All right. You can see the level of consistency that is going on. Okay. You know what? We're also being a jackass about this. We're being a jackass about everything. Sleep yield. Okay. That also. I don't care. Okay. Well, we just reduced our Weissman score to 12,897. And that doesn't even depend on the jackass stuff because the jackass stuff is totally orthogonal. This is just using a sleep yield, which is great. That is, we could delete all the jackass stuff and this would still work. I mean, not the most recent, but all right. Um, so Pocket Watch, I missed. Wow, that raid was a while ago. Hold on, I'm looking. So if you guys don't know, where there's so much chat, I don't have a shout out command, but I haven't seen Andy stream in a long time. But Pocket Watch Games streams sometimes, and they're one of the few developers who's an experienced developer who's released a number of things who streams their work. So you can check it out. Oh, you stopped at the start of the pandemic. Oh man, it's been that long. Wow. Okay. Well, cool. I encourage people to check out the Pocket Watch stream. Because there's not that many actual game developers who stream, right? Because I mean, if you work for a bigger company like Electronic Arts or whatever, you're under NDA and all that. You'll get fired. So like, you kind of have to be in control of your own studio to stream. So yeah, if you like to see what actual game developers are doing, you could check out the Pocket Watch stream. There's a few others, like Willie Chair streams sometimes. I'm forgetting some, I'm sure. Jessica Mack streams sometimes. I don't know who else. You're working with a publisher? Oh my God, are you able to say what publisher? Not yet. Okay. We do not have an exclusive scoop. You have like 5 things you can't say. Okay. Sounds like a busy time. Sounds like a busy time. All right. So our Weissman score is now 12897, which is honestly pretty good. I don't know how much that's actually going to impact runtime. But we could test it. We could comment out the jackass and just get everything compiling and see what happens. Like, because we still have those old telemetry profiles up, so we could run a new one with this in there and see if we actually got a speed boost. I would like to think that we probably did, but we'll find out. This is still more yields than I would like. Oh, notice we're yielding in different places now, too. Aren't we? Oh, no, we're not. Okay, so 0 is our total, and we have some in spot 1 and some in spot 5. Most in spot 5, interestingly. Okay, let's just say we need, in a global header file, we need to say define jackass as 0. We're going to put all this in if jackass. All right. But we don't want these to be no check-ins. We want these to be jackass. Right. And then we're going to have some double jackasses, but that's fine. We can take care of that. So this here, I'm just going to leave that. I'm going to leave that. This is, we'll put a no check in here because that's a little bit unconscionable, but All right, so We're going to replace jackass with a single jackass. All right. And then going to go here. Same. Okay. And now we're going to go if jackass around this. Because we want to be able to check in the sleep yields and then go back to the jackassery later. So this is there's going to be a lot of if jackasses. All right. Let me do this. I just want to put these in the right places. And then we'll do a pass 2 on them. Okay. So why did I do that? It was so I could just paste these in the right place. Oh, wait, no. We don't actually want... We want to leave the sleep yields in there. That was the whole point. Okay, it's just the jackass registration that we wanted to deal with. So when we yield from 0.5... Got to be careful with this because I could... So this one, we also could sleep yield. Okay, so I probably missed some stuff there, but let's see. All right. Why am I doing no jobs, though? We shouldn't do that. That takes longer. Okay, so we don't get our stats anymore because those were under jackass. Maybe I should have put those in different definitions. Anyway, you can see that it works. Let me put under the 5. Let's put this at the top. We're going to at least explain that. Going to put this up here. That I'm fine with that just being a forward declaration. Okay, so for the sub 5, does that work? Do we break anything with that one? I hope not. Yes, we do. Dang it. Okay. We'll investigate this one later. Because what we don't even know is if we pass all the tests with the other one. Okay. Does it blend? Yes, it does. Do the tests run? Now we don't need to say dash threads 5. We default to like 5 threads or something. I forgot about that. Any questions about what we're doing? What am I doing? Well, for that kind of question, you will have to go back to the beginning of the VOD and watch it. Did we write our own linker? No. So the thing is, we wouldn't need a linker if we didn't have to link to C++. All right? Because for our own language, we just already build everything together. You don't link anything. But when you're shipping a game, you got to link to various libraries that other people have written out in the world. And for that, we either invoke LLD or the Visual Studio linker, depending on the situation, and it makes us sad because it's very slow. But yeah. The function returns. Yeah, that's all yielding is. What you're saying as job, there is no job really. It's just a data structure that says where it's at. And it knows how to continue, right, if you go back in. Okay. We don't need this anymore. Yeah, some people like, so I think, for example, the D compiler, there's multiple D compilers now, but like, I think the original one was doing something similar to this, but they used fibers for it. I do not like fibers, so I did not use them. A program with no C calls wouldn't even need to call the linker when it compiled. In principle, it wouldn't. In practice, we haven't done that code path yet because every single thing we compile links something from C, sadly. But at some point, I expect we will make that work, yes. So that's like a stackless coroutine? You mean what I'm doing? No, it's just literally a data structure. Would you not need a loader for runtime relocations? I mean, do you mean the operating system's DLL loading stuff? Like that doesn't involve invoking a linker. Being dishonest about why you got timed out is, that's bannable. Like getting timed out, whatever, it retimes in 20 minutes. But if you're going to like bullshit, as if you don't know why I timed you out, just, I don't have time for that, dude. Can I please make another OS? Not anytime soon. I'm a little busy. Does the bytecode interpreter support the language's inline assembly and intrinsics? There are almost no intrinsics anymore. We deleted most of them, and the plan is to delete the rest pretty soon. Yes, while you're running bytecode, we call into inline assembly. What do we have instead of intrinsics? Inline assembly that does the things. Do we take noob questions? I'll do, for your benefit, I will do a noob question right now. Sometimes when we get rained down on by noob questions, it's too much, but once in a while, it's totally fine. Is the Braid re-release coming out, or is that postponed? It is. I'm working on it. It's in progress. It's just taking longer than I wish it did. How do you begin to understand what I'm doing? I don't know. Like, what? Just practice programming, right? When's paid beta out? I want to do something. I would like to do something by October 15. That's not a promise. We might do something sooner. We might do something later. But in my mind, I'm like, October 15. I want to do something around then. Does the compiler depend on Visual Studio libs to compile? Or does it use something like MinGW? No, I mean, what? It's a compiler. Like, we link against the Windows SDK for you to call Windows functions and stuff, but it's a compiler. Kickstarter at 2 million target. I don't want to deal with Kickstarter. When will this be in a point such that it could be rewritten in itself? 7 years ago, it was at that point. Okay, so since we reduced our Weissman score, I actually wanted to see if we got any time out of that, right? You know why I made so many mistakes being a jackass? Because we weren't powered by lamp power today, by the way. We needed the magic lamp. Do you think someone will release a game before I do? Maybe. It's cool if they do. All right, so we're going to run this. And like there's probably a lot of variability as well, but let's take a look. So in this one, make polymorph from procedure call was, let's look at percentage. Inclusive percentage 7.36. Here, $6.38. So, well, and let's double check by checking this one, this old one. Oh, it's down here. Hang on. Okay, this one, the new one is 638. I had been hoping for more, but we don't have the jackass caching turned on yet, which, like I was saying, if we can make the jackass almost free, then where are we? Yeah, here. 89 milliseconds maybe turns into, 45 milliseconds. So we would save 45 milliseconds, which, that's like, that would take 0.86, except it doesn't take that long, right? Like release. Well, I guess we have to count this one, right? But like, that's like 5% of the front end time, which is significant. If you can do that every day, then in 20 days you have no compiler anymore. Okay. What I want to do though, I want to figure out why our jackass yield from that second place didn't work when we tried to insert it. Because I would like to get both of those working, and then check that in. It does reduce a little bit of compiler time, right? Okay, hold on. Wait. Let's just start over. So in our original one, we had, and again, these are subject to noise and stuff, but again, it was 7.3%. It was 108 milliseconds. And in the new one, it's 6.38%, right? So that's about 1% down. And 90 milliseconds. So we saved like 18 milliseconds in theory, but again, that's a noisy measurement already, which is kind of okay. I'm not going to complain about that. Okay. Why can we not sleep yield from the other place? So when we enabled this, bad things happened. Let's go back to debug build. Oops. Less time and do polymorph as well. Right. Actually, you're right. Because do polymorph was yielding a lot of the time, right? So we have fewer calls to that. Actually, let's go verify as well. So here, 12,777, right? These are slightly different numbers. Actually, our Weissman score, right, came from here. So we should report this number as the Weissman score, right? So here again, we have our 47,000, where is it? 47,567. And here we have 12,777. So that's a slightly different. We're just going to put that because these numbers came from telemetry. Okay. Okay. Now what? Let's look at the do polymorph. So that's 11,865 here. For 72. And here it's 72 for, okay. Wait, no, wait. Here it's 80 for the same number of calls. Dude, this UI is hard. That's weird. Again, that could just be noise. I don't know what's the deal there. I don't like that because if we didn't really save that 8 milliseconds, that takes a byte out of the 18. Anywho. Okay, why is Babby malformed in this case? When we run with debug build. So we're yielding on something. We're yielding on the wrong thing pretty much. Let's try breaking there. So the deal is our yield upon, it's a procedure. Now maybe we're yielding for some other reason, but this procedure, it has an inferred type. And it's done with, right? So the question is, where did this happen? And we can just step through it next time, right? Let's verify that. So if we break at this site, I'm just going to continue and verify that we die. No, second time. Yes, okay. Weird. Okay, but we'll do it again. Okay, we didn't. Are we no jobbing it? I hope so. We are. So that's a little bit of non-determinism. Sometimes because we're building the game, like that happens sometimes that we wouldn't like it. Okay, first time no, second time yes. So we're going to step in and say, where do we yield? And we're going to say yield upon, and we're going to set a data breakpoint. OX B83E9A8 and go. Okay. We are waiting for this thing to get through the run pipe. Let's just change this. So we're waiting on a modify directive. You know, I know why I made that yield do what it was doing, but okay, there we go. There we go. Let's do a new telemetry build and see if we got a better Weissman score. I feel like it would go down by a little bit from that. So the deal is, when you have a procedure in this compiler, it has two compilation units for the header and the body. And when we were waiting on the body, I said we were waiting on the header, which was a lie. And I kind of know why I thought that lie might have been the right thing at the time. But that was a long time ago in development. And at this point, it's clear to me that that's not what we want to do. Okay. Let's actually make two new ones to try to denoise it a little bit. 879896. All right, so this one, timeline. Profile zone. Look at that, 8561, guys. Let's check this one. It should be the same. $85.62. Yeah. So 85.61 is our new Weissman score. Have you ever before seen anyone get a Weissman score of 85.61? It's insane. That's like a 360 no scope. Outputs one larger object file with already patched addresses and handles entry point fix up. Yeah, mostly. And then, of course, when we call out to things that are outside the executable, then those need relocations like the linker usually does, right? Or outside the part of the executable that we build, right? But everything that we build, it just already points at each other, right? Because you don't need a linker for that. Okay, we now have Weissman score 85.61. And that's really good because we know that we succeed like about this many times, right? It was a little bit less than this because we yield sometimes from here, but it was like 7,400 or something. So we don't yield that much from here anymore either. Like if we turn Jackass on again, I think the numbers will be really good now. They're relative to what they were. Let's look at the times though, right? So here, right, or originally, right, we were 7.36%. Then we got it down to 6.38%. And now we got it, it didn't really go down in percent. It's about the same, I mean, it went up somehow. That's too bad. It's about the same number of milliseconds, though. I think, so this is just noise, I think, right? So the number of calls went down, but those calls were not super expensive because they probably fail relatively quickly. But that said, you know, we want these numbers to be as low as possible for future profiles. So, you know, when we fail relatively quickly, that's less expensive. So most of this time is now being taken up by successes, right? So now if we optimize the successes, then we can do something with that. So I think it is time to explain what I did and check this in. And then we can start making Jackass less jackassy. Or we could also re-enable it and just look at the total numbers, right? Again, but all right. So here we have some no check-ins. Sleep yield infer from polymorph is copied from the typer version because we needed to say typer arrow and also return without returning a value. Kind of messy. We should factor these together later. Okay, let's be a little paranoid and run this on the tests again. Not the telemetry version, though. All right. So that seems fine. Let's run the LVM versions. See what happens. Why is the countdown of by 1? What do you mean? Do you mean why do I not say 0? Because I decided to start counting at 1. I decided to start counting at 1. Okay, so the test succeeded, and we're going to say commit sleep yield from make polymorph star. Okay. Now let's re-enable Jackass, which is both our profiling and our caching thing, memoization thing. So what's going on here is we're fanning this stuff out to a bunch of threads, but we're using the work stealing thing that's in the thread module right now. And that work stealing, we're using the, what's it called? Thread group. All right. Now this thing is not, I don't think I enabled work stealing on it yet, basically. Or maybe we do. Let's see. But anyway, okay. So the deal is this thread group is designed for like high traffic thread operations where you want minimum overhead in the thread organization system, right? Which is not really what these tests are. These tests are like you're doing a very expensive thing, right? And so for this, something simpler than this thread group would be good. However, I wanted to test the thread group all the time because we're shipping this to people, right? So this thing, if you don't enable work stealing, you can end up with some threads that just have jobs that happen to be longer than others. And those just end up in the end. So thread 1 just got more work to do by volume somehow. And everybody else finished. That's not what you want if you want to finish something in the minimum amount of time. So you would want to enable work stealing. It looks like we have it turned on, but it's not helping as much as we would like. But anyway, at some point I might just do the kind of threading that you would want for this, which is just like a single work queue. And that's more overhead to grab things off the queue, but these tasks are so expensive that it would be better because you'd have better load balancing, right? If that makes sense. Can you have a pool of waiting tasks? Yeah, I mean, the naive way to do this job, and actually which would work better in this case, is to just have one queue of things waiting and you pull something off the queue when you're free. We're not doing that here because this has a different performance profile. Okay, I hope that makes sense. I hope you are happy with this. Okay. How we doing? Anyway, so we recompiled with jackass enabled, and we should see the stats now. Okay, so we got 406 pre-crimes. We got a lot of 3 seashells, which is good. Because these actually probably aren't costing us that much, but these are costing us a lot. So this one, why did that go to 0? Because I'm not incrementing it anymore. I deleted that. Okay. We just won't report that. All right, that explains. So we only enter the function 8,714 times. That's approximately our Weissman score. We yield from these 2 places. It's not that many yields. It's like 500 yields. And we return non-matching results 137 times. So even non-matching, right, we have approximately a 4-to-1 duplication ratio. Okay. So now the question is, what do I do? Do I replace types match exactly? I feel like the next thing to do is to replace types match exactly, which is not directly on the road to, well, okay. What I can do is make a new types match exactly and just use it here. And then I don't have to worry about the jackass disabled. Or instead of doing that, I could leave the jackass disabled and do the hashing. I don't really know how to do the hashing. I mean, I kind of do actually. But I don't know a lazy way to do it. So here we're getting hash of a pointer. Where do we use that? Exported table. So if I put a type on each hash instead, why is it named Jackass Cache? Because that's what it is. Do I ever get eye strain? Not really. Only time I've really had eye strain is from wearing like bad glasses that no longer are the right prescription. I used to get eye strain a lot from staring at like blurry CRT monitors, but on LCDs, don't really have that problem. So if I put a hash code on the types, that's a semantic hash. Then types match exactly. Instead of being a recursive thing, can just say, are these two pointers exact? Which is pretty good. So let me try this. Let me try this. Well, no, because you still, I mean, in the case of a collision, I don't want to pretend like there's no collision. So I still need to write the recursive version of it. So I might as well just write that first. And then we can get rid of the, yeah, let's just do that. Okay. So we're going to say new types match exactly. All right. we're going to say if TA is equal to TB, return true, right? Exactly the same. No problem. TA number flags return false. Okay. Okay. Let's do this, right? Numbers, pointers, enums, okay, enums and structs. So now we need to do procedures. We need to do arrays. And maybe that's it. If we hit the bottom, it's no good. Okay, so if okay, okay. This actually is not nearly as much code as I thought it was going to be. Array index type? Wow, I didn't even know. All right, we'll do that. Array dementia. Wait, get array type. Oh, we forgot strings. Let us not forget strings. Okay, we need def and flags. Now, the other thing we want to do is make sure that the result of new types matches old types match exactly as well. That is a thing. Okay, strings as well. Okay. Procedures. Okay. Okay. And then flabs. Affles. Okay. I probably did not get everything, but we will do this. New types match exactly. So we're going to say this is all right, and we're going to say all right, assert matching is equal to old matching, and that'll probably break. Oops. Interp. Interp. Oh, I deleted the... Okay. I knew it. Let's see where this happens. So I bet matching is true and old matching is false. Yep. Okay. So what is the, right? All right. Progress S is that. And we go. And let's make sure we die. Yep. Okay. So here we go. What are the things that are supposedly different? Dang it. I don't want to break in an array subscript. Dang it. Okay. Number flag 0. Pointer 2. Okay. TA relative pointer type, TB relative pointer type. Okay. What else? What else could be different about these? Pointer 2. Size. Maybe the thing that's supposed to map these, like TA type info, TB type info. Maybe that's a bug. Wait. Oh, it's a pointer to an array, right? Oh, wait. I did it. I didn't check that they match. Duh. Return new types match exactly. Also, array element. Okay, I got this wrong a little bit. TA pointer 2. I knew it was too easy. Okay, so we need that. Similarly, array pointer relative pointer type is guaranteed to be unique, but here this needs to be a thing. You know, the thing. All right. Did I make this mistake anywhere else? I don't know. We'll see. But see, do the simple things you can to check. All right. Let's see here. It's probably something like uniliteral or something. TA. Wait. TA, TB. Void. TB is a struct. So I think we just do this. Because if you get down there, they're just different. Because we're switching off of TA. We'll catch if they don't match the old. Ooh. We assumed. So we're down here with something is null, which is probably array index type. Where did we get 2118? Why am I switching sides on these? That just makes it easier. Okay. So now we have a mismatch again between the old and new functions. Let's get rid of this. We're getting a lot further before we hit a mismatch. But we do have one. Okay. Now it's the other way around. Okay. Didn't expect that. We're pretty far through compilation, I think, when we hit this. Why is this taking so long? Visual Studio. I wonder if it's doing the thing where it wedges on startup sometimes. That is not even anything I care about. What is going on with these breakpoints? Why is this taking so long? We must be calling this types match exact. I mean, we're not calling it more than 47,000 times. No, we are because it's recursive. Oh, no. Visual Studio. Oh, no. This is the... Oh. No, we are calling this a lot. Because I think we're calling this for every iteration of the loop. Is that how these breakpoints work? Let's put it there. That might go faster. Wait, what? Now it's a different S. Let's try running again. Dude, Visual Studio's breakpoint evaluation is so slow. So slow. I might have to actually put some code in here. Visual Studio sucks. Amazingly much. We just have to figure out what Chunky's deal is. Okay, so the S changed, or I got it wrong. Is it the 21 S again? No, it's 339er. What about this time? Hold on. Cookie. Now it's the 421. Let's try this, because we've seen that one twice. Four, 1, 3. Maybe we'll check either of those. 3, 4, 7. Isn't that the one I just... What is going on? Okay. Let's make sure that dies. Yep. Okay. Should have stopped right there, though. Okay. Let's see. I mean, we should make sure it's I equals 0. Nope. I equals 1. Nope. I equals 2. Yes. So on the 413, it's I equals 2. It might be different on the other ones. Didn't even catch it that time. Why is it so? Are we not no jobsing? We are. I don't know why we're not deterministicing this. Okay. 413. So it's number 2. 0, 1, 2. Oh man, we have to deal with this. Is there a step into in Visual Studio still? Okay, so it's a procedure. So, okay, there's some kind of procedure flag that we're not checking. Let's go look in. I should have done this before. Wait, yeah, we make fucking type hashes for lambdas even. We make hashes for everything, so we just have to move the hash, really. Okay, hold on. Wait, we're letting things just collide here. That's bad. Wait, this could be two types that actually don't match. No, wait, we were returning true. They were returning false. Okay. Oof. What was I doing here? This is not actually good. Because we could, if we have a collision, we could cause your program to fail. And even if that's a low probability, you could adversarially cause that to happen. F11, no. F11 steps into anything. I want to step into the current line. It's probably like control F11 or something. Okay. Find or add. Okay, hash items match. Wait. Maybe we call this, yeah, maybe I need to look into this later, but anyway. So we have compare for procedure. Procedure flags. Right, that's... Oh, we need to check defen flags, probably. We do. Okay. We do return types, argument types, and procedure flag. Okay, where does procedure flags come from? Def and flags. Def and flags. Let's just see where these come from. Line 297 of preload. Line 213 of preload, okay. So we have allocator and we have default allocator. And the difference here is going to be, okay, so these are the same type, but their def and flags are, wait, I thought the def and flags are going to be different because there's a flag that's like a utility flag that I'll show you in a second. Okay, yes. So now this flag is going to be the following thing. Type definition, we only want the function type. That should be irrelevant for comparison. So you see they're equal if I mask that off. So the problem, we already check for type match between these things. But one at a time so we can do good error messages. So there's no definition. So we need to do const u32 type def and flags for lambdas to be different equals all this crap. And this is going to be, this is an error prone thing. Anytime you do this, because you add a new flag, actually that even is not. You add a new flag and then you're sad because you forget. Is packing variant still a thing? Nobody checks it. Nobody calls that. We get to make gains by deleting stuff. Not a lot of stuff, but like, you know, we can delete that. Okay. Is polymorphic. That definitely counts. Definitely counts. Data pointer. This is not really a thing right now, but it probably will be a thing. This is definitely a thing. This is definitely a thing. This is definitely a thing, I guess. That actually, yeah. I don't know about elsewhere. Okay, let's go back here. Okay. So we mask by this. Now the thing is, I think we're still gonna be a little bit different. Let's start talking about the value that we're adding to. Small speed up in polymorph routines, 10 to 20 milliseconds for the Sodan game. Ain't nothing. Ain't nothing. Okay. Now we're still going to mismatch, but we may start mismatching due to bugs in the old handler, which we want to know about if they exist. All right, so we definitely have a disagreement. Now the question is it in a new thing or not? And let's remove this breakpoint for a bit. Okay. What is the S? It's this thing. You know, these aren't side effecty. Okay, there's an easier way to do this. We break here. And then we do set next instruction. Way easier. Okay. Matching and old matching. Matching false, old matching true. This, I suspect, is due to the lambda flags. So let's just see. Dang it. Don't tase me, bro. Okay, so these are going to be procedures. Okay, so we're going to just say, what is this? And what is this? Okay. But what is TA type info procedure flags? Type info procedure star. And what is this for B? Oh, okay. Well, wait, did we say we returned false? Hold on. Oh, we returned false on one of the arguments. Okay, let's try that again. I think it was argument. Oh God. No. Don't do this to me. All right. I think it was argument 1. No, it was argument 0. Dang it, dude. Set next statement. Go to there. All right. What are these types? God damn it, dude. Control F11 opens disassembly. Shift F11. Does nothing useful. Grr. Hate this. All right. Shift F11 goes till we come out. All right. Let's try it again. Set next statement. Run. No. What happened to my breakpoint? Set next statement. Here. Go. And then here. Go. All right. Okay. What are these? Polymorphic variable. Okay, defines constants block entry. Oh, because we run. Right. Okay, I get it. I thought when I was writing this that I wouldn't have to handle this. So TA defines constants block entry. And then do we treat these as equivalent? What does anything counts as the same? Okay, let's do that. Okay. We're just matching the old behavior. It may not even matter for us to match the whole old behavior for this particular use case, but if we're going to swap it in for our other function, we want to match it. Well, it may not honestly matter, but to be conservative, we do want to. Okay, matching is false, old matching is true. Set next statement. I could even get rid of the set next statement using this one weird trick. Okay. So let's see. Not number flags, not pointer, enum, struct, array. It's going to be a procedure. Oh, yeah. Procedure. It's a polymorphic procedure. Oh, wait. We're not checking type definition is polymorphic, by the way. Okay, this first argument didn't match again. It's as if I had changed nothing. What? Oh, I put the line in. Okay. I put the line in the basket so it gets the hose again, guys. Guys, it puts the lotion in the basket where it gets the hose again. It also puts the lime in the coconut. That is the true. All right. Okay, now what is different? Oh, no, let's use our one weird trick. Our one weird trick is, let's put a no check in here so we don't forget to delete that. Our one weird trick is that, bro. In fact, look how awesome that is. Okay. So matching is true. Wait. Why are they both 204? That's OXCC. That's uninitialized. But it says they're not equal. But the debugger thinks they're equal. I'm getting trolled. Oh, it's because of these down here. Okay. Okay. Let's not. My one weird trick was too weird. All right. So, matching is false. Old matching is true. What have we got here? It's a procedure. Okay, this, it's going to go down to here. Okay. No, the flags. The flags are the same with polymorphic. So it's got to be one of the arguments or the returns differing. Is it a return? I bet it's this right here, right? Yep. Okay. Well, we'll do that again. Okay, what is this that we are returning? Fudge, dude. Shift F11, right? Okay. So, enum struct array. Okay, so these are both like some other polymorph. Disable matching in this subtree. Oh my God. Okay, let's see what we do about that. That's another thing where I would need to think about it. Okay, this is confusing because it looks like we only do this in this case. Okay. Like, I kind of don't want to trace into when these get frickin' set. But let's see if it's constant. So this one's 677. Let's see if we get that again. Whoops, this is not what we want. Okay, now it will be. Six, seven, eight. Dang it. Oh, wait. No. Hold on. This is the wrong thing. This is the wrong thing. We want to go here. Now what's TA? 677. Okay. So here's what we're going to do. We're going to go to type table. And I want to figure out how this gets mapped because I don't see it in any obvious way. Okay, here we go. Make sure there's no substitution. All right, so conditions TA arrow S is equal to this. TA is undefined, right? Because it's not called TA here, it's called expert. Wait. Not expert. There we go. Actually, we don't need this because we have a separate add for a type definition here. Which all those guys are calling into. All right, let's try that. How is Babby formed? We don't want that right now. Tell me how Babby is formed. Tell me. Tell me. Okay. Translate type. Wait. We already checked type info in progress. That's more gains. Dude, we get 2 gains before we end the stream. Okay. Even if we turn off Jackass, we still get gains from these. Okay. It's just a few lines of gains right there. Array element type, struct, desk, disable matching in this subtree. Oh, we copy it from the subtree. What? Oh, no. Okay. Okay, so that just means back on... Why do I have calculators? Go, goodbye. Back on the ranch, in new thinger, we say okay, and then we're gonna go return okay. That should account for this. How low do I think I can get the Weissman score? We're actually done working on that Weissman score at this point. That's about as low as we're going to get it. And we will make a new Weissman score later. But I'm leaving it up because I am proud of that. That is a good ass Weissman score. Wow, we made it all the way through Sokoban without our assertion tripping. Okay. 3 seashells detected. Let's try the tests. Interesting. We passed everywhere. So here's what I want to do. I want to check this code in, but I want to disable jackass. All right. I want to put this, okay. That ended up being more code than I thought when I was saying, oh, I'm so happy how little code it was. How much? So from line 2100 to 2166, not that bad in the grand scheme of things. It's going to break, unfortunately, but okay. So we call that a bunch. Okay. Did our jackass statistics change? They shouldn't have, I hope, unless I made a mistake by much. No, I mean, we're still like 87-14, which is a stone's throw. Remember, this isn't really quite the same Weissman score as what telemetry gave us, but there we go. We actually might have increased the yield slightly for some reason, but it's, you know, we'll verify that later when we do a telemetry run again. So again, these are mostly 3 seashells, which is something we can speed up to get time. But I don't know if we're going to do that tonight because we're just raising other issues that we want to take care of. So we're going to go here. We're going to say jackass is 0. We're going to make sure we pass all the tests with jackass at 0. Just making sure it still works. And then we'll check this in. And then we could switch over. Our old types match exactly to this. And that should in principle be good. And I'm going to put move hashes because if we move the hashes over, then everything is real good. Any compile time gains today? Yes, but so far not huge, like maybe 10 milliseconds on the Sokoban game. But we're laying groundwork for maybe another 40 milliseconds or more. That'll be 50 milliseconds, which is almost as much as the human eye can see. Okay, so first we're going to check this in. Does not depend on messaging to have happened. Boom. That is just a win. Okay. Now, packing variant, we're going to get these gains. Let's count our lines of code. They're getting up there. 82K. A lot of that is these ASM tables, but you know, got to do what you got to do. 82720. Are there any stupid files? I don't see any. Okay. Now, packing variant. Let's get rid of that. Bam. Make packing variant. Bam. Make non-relative pointer. Can't say that's like make packing variant anymore. Make packing variant was a thing having to do with the old SOA implementation. Okay. GG's. How about... okay, so we were 82720. Type info in progress. This one is stupid because we literally checked it up here. So there's like no reason to do that one. I think that's old. Let's do this though. Let's do a simpler one. So we're going to pay a line here to go this in case it changes. Dude, this is so horrible to try to type it. How does anybody use this? How does anybody use this program? In case we modify or remove the check above. So there we go. So now we're going to go 82706. So we made 14 gains. Not huge, but it counts. Okay. That's good. Remove some vestigial code. Now what? What do? We start converting types match exactly to new types match exactly. I'm going to try this. And this is a no check-in bagger. And let's see if we pass that. We may not. We did fail something. Struct deduplication. Okay, we can do our same trick right there. Same trick. Same trick. We're going to go old matching is this. That's a no check-in. And we're going to say and we're going to do our one weird trick. And we're going to go there. So why are these different? Oh, we got to run the right test. La 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 la. Compile time assertion failed when we're saying type of some different things. Why? Why? Oh, hold on. Does it not happen with no jobs? Oh, we're just exiting here. Yeah. Okay. Oh, we're not. Okay. Whoops. So we especially made it not run, but I'm confused about this. How do we not hit this breakpoint? Why did it pop that up? Dude, Windows is so broken. Okay, wait. What if I do this? Does that break? Wait, it still breaks? Oh no, guys. Was I cavalier and didn't test after we deleted some lines of code? And like make packing variant actually mattered? Hold on. It shouldn't have because nobody called it. Type of T2 is equal to type of T3. Like we literally just did this. I think. Wait, no, maybe not. We literally just recently did a related thing for compound declaration desugaring. This doesn't fail because we fixed it. Those were notes from the original repro. What just happened? What just happened? Oh, we're not returning true. Okay. Okay, I am slow. I'm on the slow bus. What file was that even? ass.cpp. Okay, return matching. Bro, that was the right way. This is the way. This is the way. Okay. But what if I say new? I bet that's fine too. Nope. Nope. Okay, now, okay. So because I broke that, we didn't get far enough to the point where this happened, but now we are. Matching true, old matching false. What's going on? What's A? Oh God. It's something made by the system at startup, and so is B. Interp type def type. Interp type def poly use. Interp type def unary literal. What are the flags? Oh, let's hold on. Let's see that. Let's see that. It's a pointer to... Wait, why did it look... Oh, it's one of the... Okay, so this is a pointer to... A pointer to... An array... Wait, where were these made? An array of void... of dimension 4. This one is a pointer to an array of dimension 0. So why are these getting the same type info? This is 7518898. This is, wait, no. They're not the same type info. What? What about this? TA type info. TB. Oh, this is false, and I said true. But wait, I check array dimension, though. Didn't I? Nope. Dude, I swear it was one of the first things... It was one of the first things I thought of, and then I just didn't do it, or maybe I accidentally deleted it. Okay, well, there we go. This is why we test things. Okay, that's cool. That's cool. So let's go back to there and remove this. Boom. Boom. Just run that. Run it back. We should make sure soak will ban. And then meanwhile, okay, well, these are obviously recursive calls. This is baked literals match exactly. Wow, there's only one call left to it. Which is this. Okay. Let's go ahead and just try this. That's in typer. Let's put a no check in there. Whoops. Forgot to change that. Okay. Wait, not that. Oh, we never did Sokoban. Gotta do that next. Gotta do that next. Wow, okay, this is major. If we get rid of types match exactly, that is major. Major. Hey, hey, hey. Hey, hey, hey. All right. Yeah. And let's get our gains here. Now that said, we did add code because even after deleting this, we added something that was like 60 lines. But that's okay. Let's run the tests one more time. And so that's good. We got perf gains. We got robustness gains, although we're going to continue that refactor, I think. The question is if this function is realistically slower than the old one. I kind of don't think it is because what were we? Baked literals match exactly, which, you know, that gets called in deduplication, but even if this got a little bit slower, we're about to end run this. Anyway, because we don't care if constants blocks match. I don't think. Oh, shit. Okay, when it comes to the jackass, we're actually not doing everything necessary. I don't think. Because it doesn't just depend on types, right? There are auto bakes. So we need jackass auto bakes, which I don't think I'm going to do tonight because I think I deserve a break soon. You know, we've been going 4.5 hours. We made some robustness gains and some perf gains. So this hashing, okay, so what do we use the hash for? We just I think we just look on the new info for the hash. Wait, what? Oh, no. Okay, that's fine. So we set the hash. Type hash. Wait, just add doesn't put things in the type hash. Wait. Oh no. Oh no. That, we might get an extra Weissman score. Because maybe we had too many. Okay, hold on. Hold. We may have duplicate type table entries. Because of this mistake. Or if it's not a mistake, I don't see why it's not a mistake. Type table packer. Pack data for type table. Okay. Okay. Whoops. We want Sokoban. I want to see the types. Wait, where is it? I said... What? Let's just put it here. Right here. Oh, because we're not in debug. Lol. Lol, 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 lol. Lol. We weren't running the thing. We were compiling. Okay, now because jackass isn't turned on and I inserted it into the jackass. There we go. 10.434. Okay. If I comment this out, does this number go up? No. I kind of don't understand why this number does not go up. It looks to me like it should. Oh, I guess... No, I really don't know. I don't know. Why this doesn't result in a difference between these two cases. Don't know what to do. Ah. Okay, I'm just going to leave this. I don't understand why it doesn't change, but that's okay. So let us make the roadmap for the future so I can take a break and go to bed eventually. The roadmap for the future is actually, I don't think I want to move the hashing stuff like I was saying, at least not for a while, because I think it makes sense to do that eventually, but it's not necessary for now because, like I was saying, I don't think perf is really going to be affected either way. So that would sort of be an optimization to move it. And, you know, we're running at about the same speed. I mean, obviously, the number goes up and down, and of course, it's much lower when we're not streaming. But, you know, this is about what we expect. It's a little lower, actually. No, it's about the same. It's about the same. Maybe it's a little higher. I don't know. We were like dividing by 0.756 yesterday. I remember that. So, you know, we're in that neighborhood. So the plan then, if I'm not going to move that hash, is to do the better version of Jackass. But we need to make it do auto bakes correctly. And it's a little bit challenging because I'm going to write down plus repro because we weren't doing auto bakes. And when we turned Jackass on, nothing broke, which means we don't have a test case that calls a function with like different bakes and asserts that it's different, right? So we need to make that repro and make sure that Jackass succeeds in that case. Oh, actually, one thing we can do before we sign off is the whole reason we needed to do that Jackass enabled. Hold on, let me check in, right? Because we changed something. Oh, yeah. Okay, fix new check that types match, switch to it. The whole reason we had to do that Jackass enabled stuff for like an hour in the stream. Was because the type table entries were not necessarily ready. But what we can do is get rid of Jackass enabled. I mean, there's two. We can turn on Jackass from the global header file and get rid of Jackass enabled. And then make sure that that works, which is good because it will simplify that. And Jackass will be running for 100% of the cases, which is what we want. Okay. I got to get rid of this thing, by the way. Why? We're building release. Lol. The Wiseman score was pretty good today. I didn't expect it to go down that low, and it did, and that was great. Okay. So we're going to go back here. We're going to turn Jackass on. Now we're going to go to polymorph. And this thing, so what we could do is this. And we're just going to fully enable it for now and no check-in because we want to get rid of the variable completely. Now we're going to get rid of this pre-pass, which is good. And then we're just going to condition on this. All right. Actually, we could just make it the error. We'll see. Dang it. Oh, I still have an assertion in there. We don't care about this assertion because we don't need that type info anymore. I might have other old ones. There we go. We completed the deal. And we now have 0 Jackass disabled, which is great. And it's about the same amount of pre-crimes. So getting rid of that. Very good. Very good. That was the whole point of us doing that. Well, not the whole point, but that was the forcing function. Why we wanted to rewrite that types match exactly right now was so we could do this. So we still haven't capitalized on the 3 seashells. To do that quickly, we're going to want to make Jackass better. Because otherwise, we're doing 16 million comparisons because it's n squared. That's more comparisons than we would like to do. Okay? Okay? That's probably a reason to do the hashes. Because then we can hash the hashes and just put that on our Jackass record. And if it doesn't match, GG's. So hashes, and then jackass hash table. Sounds good. And we could even compute that once so that if we yield and come back, we don't have to recompute it. Okay. Pretty good. Pre-crime. Everything's working. Okay, so when it comes to deleting this, do we want to or not? Let me see. That just controls now whether we register the... Yeah, let's do this. So we can keep the variable around. We just don't have the messy pre-pass. Okay. If we wanted to, we could put the jackass types on the progress. So that we don't have to fill it out. Because that's just one of these messy implementation details. I mean, actually, we could make the jackass result and just not file it. So if the jackass result doesn't exist, then we make it, then we could have that array on there or whatever we want. Because we're going to record it anyway. Let's make sure that we haven't broken. I kind of want to do this. Okay. We don't record jackass disabled now. Thank you. Thank you. Okay, so... What do I want to do now? Let's make sure the game actually runs. And then what? Let me put a new line here so I can see that if. I think I want to put a jackass record on progress. Okay. And we'll make the result an enum. Okay, so Why can I not find this? Okay. We're going to put a thing here that says struct jackass polymorph info jackass polymorph info is null. Okay. Okay, so what we're going to do here is we're going to say if jackass enabled, okay, if no jackass polymorph info, okay. That way, if we yield and come back, we don't do any overhead again. Although, maybe I don't like this. I don't like this, actually. In my experience, most of the web people I've met who think they're good are bad. Which doesn't mean that there aren't some who are good. I'm sure there are some who are good. It's just most of the ones who think they are good are not good. Just like with a lot of things in the world. Okay, I just want to do the following thing. I don't actually want to do that. I want to instead okay, if okay, this is just here in case we insert casts on top of stuff. Check that types match. Right? Maybe we could use argument list unsorted. That is definitely a thing that could happen. Except we'd have to deal with names at that point. Yeah, let's not. Memory is no longer needed once we have determined whether this polymorph succeeds or fails, but we don't have an easy way of freeing right now. Okay. Jackass types. Progress arrow. Progress arrow. Okay. So at least we don't recompute those now if we yield, which is a slight speed improvement. Let's make sure we didn't break anything. How do you even know you're actually good? You look around at what other people are doing and ask, could I program that at all, first of all? If you can't, then it's like, okay, that's something to learn, right? And then secondly, could I do it as well as they are, either in terms of speed of implementation or bug rate or whatever? Now, lots of programmers are not that good, especially because it's such a growing field. And most people are inexperienced. So you actually have to compare yourself to experienced, effective people, right? That's how you get better, is you look at what those people are doing and you say, I would like to do that, right? Compare yourself to John Carmack. Yes, that is a good way to do it. If you compare yourself to John Carmack, you'll be like, oh, he's better at this than me, and he's better at that than me. And you're like, okay, how do I get better at this and that? That's exactly how to do it. Okay, we're still getting the numbers we expect out of all the jackass. So that's good. I am ready to call this for now. So the thing to do next stream is to look at these bakes, because they matter. The problem is Like this is going to be annoying to jackassify. Although this may involve just moving some of this information upward. Like it's quite possible maybe that we could do this earlier. The problem is, what if we did a cast on an argument and it's a value bake? Anyway. We can, because jackass is toggleable, we could do whatever else is necessary to make it fast. The problem is this yields, which makes it messy. It makes it messy. There's some code here, everybody. We could also just not jackass if there's auto bake, because it's just an acceleration structure. So we could actually say jackass is not enabled, although that will also include all structs. Which is a bummer. I kind of don't know how that didn't just totally, oh, wait. It didn't totally hose things because if I go up here, right? If we succeed, we're not returning the success function. So that's why we're not returning incorrect results in some cases, because we're just going and doing all the work, right? That's where that other 40, 50 milliseconds would have come from, is returning the result here. But we can't do that. Yet. Okay. I am going to go back. I'm going to disable Jackass for now. But that's where all the speed is going to come from, is not doing polymorph when we're re-invoking successes. But that's what we could do, is actually, okay, we could do accelerated Jackass for things that don't have auto bakes, right? And just make that work. And that'll be a certain amount of stuff. And that'll get us some speed, a lot of speed. But then the struct part comes a little bit later, right? Okay, thanks for hanging out tonight, everybody. You know, it's all good. Simplify Jackass stuff. Okay. So that's the plan. Okay, so plan is move the hashes to the base types. Use that to accelerate new check that types match. Make sure that doesn't change any results. Then use that hash for the type table. Then use that type for Jackass. And we don't even have to put it in the hash table to use it. We just have to verify that hashes are the same or not the same in ways that match the answers we are already getting. And then once that is all in, then we could put that in the hash table. And then polymorphing should be a lot faster, hopefully. At that point, we should be able to turn Jackass on or off and see things get, I don't know, 50 milliseconds faster for this, right? Maybe a little less, 30, because it's profile version versus non, right? But you would see this go down from 0.65 to like 0.62 or 0.61 if we're very lucky. And that doesn't sound like a lot, but A, every little bit counts, it all adds up. B, like as the program grows, that becomes more important, right? And it means you don't have to worry about leaning on polymorphism and doing it a lot, right? Did we even make, let's make a release build. Anyway, so this is 0.757, right? So if we take that as our timer, then we get 166,117 divided by 0.7575, right? So that's 219,000 lines per second. But if we get our 40 millisecond, or let's say 30, which doesn't sound like a lot, it's 5% speed though, right? So that makes us 0.7275, right? So 166,117 divided by 0.7275 is 228, right? What was the other one? 219? So that's an extra 9,000 lines per second just from doing the jackass. And that's while streaming, right? When we're not streaming, the numbers go down. So we'll see. All right, thanks everybody. Thank you for coming by. I'll see you later. I don't know if we're going to stream this weekend. I've got a lot going on, but maybe we'll do a little members only stream. See you later.